So I'm going to share my screen once again. Can you see my screen? Hello? Can you see my screen?
Yes.
Okay, I'm going to open up the data we've been using. Okay. So if you remember, this is the data we've been using. So I think we've looked at under the analysis, we've looked at how to check for normality, and we've also checked how to do frequency, has to also do descriptive. Then the next thing now is for us to look at how you do chi-square, how to do chi-square. Then after which, then we'll go and look at how to do ANOVA, and I think we'll deal with t-test, but I'll just repeat it. Then we also look at how to do correlation. Then probably tomorrow we'll look at how to do correlation and regression. I think basically those are the things that are left for this level. So now, for the sake of emphasis, now once you have your data open, you've coded, you've done all the transformation, and the next thing you do is to want to run either frequency or descriptives. And I said frequency is usually when you are dealing with categorical variables most times. You can also use it for continuous variable, but it's more appropriate for categorical variable. For example, let's say I want to check the number of let's say the number of cases, the different age group. I want to check all those, then I'll move that here. Then I can decide to say, okay, I want to check for, cannot do me or median here. Or if it was still continuous variable, we can click any of this. So let's say I want to check chart. Okay, I want to see their pie chart or bar chart. But if it's continuous variable, then you can use histogram. But in this case, let's say I want the bar chart. I want them represented in percentages. That's fine. The frequency is just to say that whether descending or ascending, but we are not doing this. So you can either display frequency or not, as the case may be. Then click on OK. So basically, this will bring out the your frequency. It tell you the number of data you are looking at. We are looking at 32. Each of them is 32. Then the cases. Case is 81. The control is 81 to tell you the percentage, the valid percentage, and cumulative percentage, as the case may be. But the most important one is just this percentage or valid percentage, as the case may be. And for the age group too, we also have the different between 28 to 20 to 25. You can see there are 10 of them, and this represents 7.6. Then with between 26 to 30, we have 68, which represent 51.5. Then why the between 31 to 35, we can see they are 31, which represent 23.5. Why the between 36 to 40, you can see that this is what they equally represented. Then after that, you can see the what's it called? the bar chart. In case you want it to be in bar chart, you can also do it, see it there. So that's that. And if it was a continuous variable, all you need to do is to also still frequency. You want to, and let's reset this. So let's say you want to check. Let's assume we're looking at age now. All these continuous variables. Then you move them here. But in this case, we are going to check out frequency, because what this means is that it's going to be representing each one value, which is going to make it cumbersome. So here under this statistic, we want to check. We want to know what the mean is, the median, the mode. Let's say we want the quartile, let's say percentile. Say we want 25, add 50, add 75, you add, you add, and let's say 95, and you add. So we want that. Let's say one standard deviation too, one standard error of mean, one range, variance, whatever, all this. Let's say you want all this, as the case may be, and all of that. Whatever you just click there, OK, then you click OK. So you can see that it will automatically generate this for you. They tell you the valid value, the missing value. This is the mean. This is the standard error of mean. This is the median. This is the mode. This is standard deviation. This is the variance. This is the skewness. This is standard error of skewness. This is kurtosis. Standard error of kurtosis. Then we have the range. Then we have the minimum and maximum. Then we have the percentile, the different percentile. So basically, these are just the basic things you will run before you start running, doing comparison of whatever thing you want to do. And after you've done that, let's say now we move further to say, okay, we want to check for chi-square. Then under here, when we are dealing with chi-square, you cannot you cannot compare continuous variable using chi-square. So meaning that basically what we can want to compare now, let's say distribution of case control in relation to age group, for example. So now let's say we want to check if there's relationship between uh, cases and control, and also in the different age group. So in this case, we can want to say, okay, exactly, we don't need to check anything here for the statistics. Then remember I told you that before you can do anything here, now before you can even compare, there is something that you are supposed to do. Now let's say we want to, even before we want to just check first and foremost, we want to display this compressed table. So let's say we want to see, okay, we want to check. Remember we say for you to use chi-square that it must be greater than in each of the boxes, we must be sure that at least 5 they are greater than 5 or equals to 5, sorry. But if it's less than 5, then you use
Yes.
what do you say?
Is that T-test?
Not t-test to Fisher
Okay.
exact test. We are
Mm.
talking about categorical variable here, not
Okay, okay, not
continuous.
continue.
Mhm.
Okay.
So use chi-square here. Then you can also want to check for risks. Or want to check for, that's okay. Basically this. So you click OK. Then click on cell. Let's say you want to see, want to check percentage for row, column, and percentage. Then you can set OK. So for example, if you were, let's say you want to check Z score, for example, we want to also check this, but we are not really dealing with this. So click on OK. Then click on format. There's nothing changed there. So if you want bar chart to be displayed, you can click on that. So you click on OK. So you can see that first table is the summary. and this is the second table. And you can see this second table actually show us now. You can see that this is the case for the cases 20. You can see that we have between 20 to 25, we have 6 here, we have 41 here, we have 17 here, we have 17 here. Then for this one, we have 4 here, we have 27 here, we have 14 here, we have 6 here. Then you come and check the total. You can see that the total is okay. Then this is the what's it called? This is actually the chi-square test. You can see this Pacemaker chi-square. You can see that the value is 2.125 with degree of freedom of 3. And degree of freedom is usually n bracket n minus 1. So what we are saying is n bracket and n bracket, let's say arrow minus 1. N is number of rows. If you look at this particular one now, how many rows do we have here? This case control, and this 1, 2, 3, 4, 5. No, 1, 2, 3, 4. So we have 4 columns here, then 2 rows. So we have, it will be 2 brackets 4. Are you with me? Are you here?
This thing is it not 5?
No, it's not
8.
5 now. This 1, 2, 3, 4.
Okay, this last one is not part of.
No, total is not part of it now.
Okay.
So it should be n, should be arrow. That is a n minus 1 bracket arrow minus 1. So what we are saying is that 2 now, since we have 2, 1, 2. So it will be 2 minus 1 bracket 4 minus 1. So we have 1 bracket 3. So that's how they got this 3, this degree of freedom. So this is the p-value. They are assumed statistic, two-sided. So it shows that there was no statistical relationship between age group and the subject classification. So these are the different pie charts. So that's that. So let's do another. Let's say still on that. We want to do. Okay.
This one now, it's categorical variables. That's when you use this
A variable. Yes.
pie chart,
Chi-square.
chi-square. Then for the graph now, the pie chart and or bar chart. Then the other
what?
one that you use histogram is continuous
Histogram.
now.
That's for continuous variable.
Continuous variable. Okay. Then
Yes.
these other ones for this categorical variable.
Variable. You can either use bar chart, pie chart, as the case may be. Yes. So yeah. So we are still on that what's it called? On this chi-square. So let's reset this. So let's assume now we want to so let's assume we want to so let's assume that now we are still dealing with this case, but instead now we want to compare it with let's say Latin classification. Yeah. So it's same thing here. We are not checking anything here. Under this statistic, we are checking for chi-square, then we are checking for Ricks, then we are checking for Mark Newman, then click on OK. Then for cell, we want to check the total row, total column, then total. So we click on that. Then we click on, if you want to display the pie chart, you can also do that. So you can see that we have, now you can see in this case now, sorry, it was age group I moved. It's supposed to be um it was supposed to be here was supposed to be cases, not age group, subject classification. Although the analysis is still going to be correct if you but although there's something I'm looking at, that's why I brought now for the age group. What we are simply saying here is that between 20 to 25, it was only one that have hyper prolactinemia, while 9 had normal prolactin. Saying among 26 to 30, 11 had hyper prolactinemia, while 53 had normal. Why among the 31 to 45, 7 had hyperprolactinemia, why this had. Then among the um among 36 to 40, you can see 11 had. So now if you want to check, now come to start, you can see that looking at here now, you can see that the statistic here, the Pearson chi-square is statistically significant because this is 0.013, which is less than 0.05. Is that clear? Then this is the value of the chi-square, 10.834. Now, where we are really going to is actually now looking at case control. Now, consider this hyperprolactinemia, that same one, but we are looking at 2x2 table. Now, for this 2x2 table, you can see for the cases out of the 81, 30 had hyperprolactinemia, while 51 did not. Why the control, they did not. All of them were normal. So when we come to check here, you can see that here we have, you can see that they are statistically significant too. Then we also have the pressing exact test here. You can see is also statistically significant. So in this case, we'll also go ahead and use the Fisher exact test. The reason why we use the Fisher exact test here, remember that one of the boxes had 0. It's less than 5. Is that clear?
Yes.
Okay. So any question before we move further?
No, for now. On my side.
Okay. Move to the other aspects that I want to look at. Now, we've talked about mean one sample t-test. Then let's just look at independent t-test. Now, under this independent t-test, now we want to check, let's say, all these continuous variables. We want to check. What their values are going to be. Let's move them here. What their value is going to be. Then, but we are going to be checking them. And remember that t-test, when we are dealing with t-test, that will be 2 groups we are comparing. So here, we define, we have 1 and 2. So if you code your 1 and 0 or whatever, you have to put them here. So continue. Then we'll click here. We say yes. Okay. Then we'll click on okay. So waiting for the outcome. Okay, yeah, we have our result out. So now the first table is going to be summary, almost like the normal descriptive that you will do. It will tell you what the mean there is, standard deviation, and standard error of mean for every of the analytes you are going to be uh, analyzing. You can see that. Then this second group is actually where we get the T-student test. Remember that when we are dealing with T-test, what we are interested in is this T-test value and this other value, and this T-student, this significant 2T. So here for this first one, you can see is not statistically significant. But the second one, we are looking at FSH. You can see that when you compare the FSH between the mean FSH between the male and the female, you can see that they are also. Now, another thing you need to note here is we have two output you're going to be seeing: equal variance assumed and equal variance not assumed. So here you are going to assume equal variance not assumed because they don't have the same variance. So is the second value you're going to be taking, the second statistic. You can see now we have two here. You can see here, and then you can see here. So this is the one you are going to be dealing with, this one. So now for this second one, this is the value you are going to take because we are assuming variance are not equal. So here we have 3.696. Then the p value is 0.00001 as the case may be. Then the second one is the LH. So you can see that we're also taking this. This is 3.397, which is 0.001. Then the fourth one is prolactin, which we've also seen. Now remember that when you are reporting, you are going to first and foremost copy out the mean and this or standard deviation and standard error. Then you will now come and have t-test. Let's say you have a let me just open one let me open up new something like this. And if you are to report um the t value for all those statistics I just did, you have a table like this. So let's say we have a table like this. Then this will be the let's say this will be mean. So standard deviation. Or most times you have mean plus or minus. Coming to have mean here, we have plus or minus. Let's say standard error of mean. And we have t-test here. And we have p-value here. So this is how you report. Let's say for this one, let's say we are dealing with FSH. So you come to this place. Now for the FSH, but another thing you also remember, we are dealing with case. Let's say we have another. So remember here we are dealing with, okay, let's say here we have case and we have control. Are you with me? Are you with me?
Yes.
Now, for the case, let's go back to our output for FSH. Is FSH. The case is 12.04. So this is 12.04. And plus or minus, then you go and check the standard error of mean here. Standard error of mean is 1.63. 1.63. Then the control, let's check the control. We have the control is 5.92, 5.93. You approximate the last one, 5.93. Then plus or minus. So what was the, then we have that's 0.25. 0.25. So now, what was the t-test? Then you go back to, remember that you will not see that. You have to come to this place to check what the t-test is. And the t-test here is 3.69, 3.6996. 3.696. And what was the p-value? P-value was 0.001. So you say less than 0.0001. So this one you can either have remark here, remark. So here is if it's significant, you just put X. Then you come and tell them that S, and that is under key now, normally for your table when you draw your table. So S is equal to statistical significance. So if it's not significant, to be NS, which is not significant. Significant. So is that okay? So you do the same for, let's say, LH. You do the same for every other parameters. So that's how to report that. So any question at this level?
That one you did now, you did the last part as in after analyzing, trying to
Yeah,
report it.
that's the how you report it in. Yes, yes. Okay. So let's move to the last part of today, which is ANOVA. ANOVA simply means analysis of variance. Are you with me?
Yes.
Analysis of variance. So now, for you to do ANOVA, it means that you have more than one. This one you are comparing more than two groups. You know, for t-test, you are comparing just two groups.
Mm.
Hmm?
Yes.
Then for ANOVA, but you're comparing more than two groups. So now for this, click here. Now you come here and check age group here. because it's only age group will have more than one group. Then you move age group here. Let's say we want to check um, FSH, then want to check LH. Now under contrast, we are not dealing with anything, so you leave that out. Under now, another thing under ANOVA, there's something we call post hoc. Then under post hoc is like internal comparison between just the way you are comparing, just the way t-test is. But for ANOVA, you now want to compare internal groups across groups. So there is an inbuilt of a form of a t-test statistic within ANOVA that helps to compare between two groups. Then these are the different these are the ones that assume equal variance. If you are assuming equal variance, then you can use any of these ones. But if you are assuming equal variance not assumed, then you use this. Now, assuming this is SLD is one of the most popular ones. So in this case, let's assume we are assuming equal variance, then we use SLD. Then you can also use Bonfinorin, then you use this. So click OK. Let's assume we are saying they are not equal, then we use this. But it's one you can use at the time. I'm just using this for this purpose. So you click on, you can use SNK and all the lines. So this one will help you to compare between the value of whatever you're analyzing within the different group. Then Ocean, then we want to report descriptive. If you want to have mean plot, you can also do that. Click OK, then you click on OK. Now this is what now this is almost the same thing that we saw um in the mean. Sorry, when we check the descriptive, you can see that for FSH it reports the mean for those one within the group of 10, 20 to 25, 26 to 30, just like that, and standard deviation and every other thing. Then this is the ANOVA table. Now this will just tell you if age group is a factor. Now looking at, you can see that age was not a factor for FSH and LH here by the virtue of the statistical value. But now, for us to now understand it better, now what this do for this post hoc test does is that what it's doing now is that it will take, let's say, across the 20, it will try to compare the mean value for 20 against 20, that is 20 years to 25 years to 26 to 30 years. We compare them and check whether it's significant. I see it's not significant. Then the age group of 20 to 25 to compare to 35, we are checking the FSH value now, checking the mean value of the values for this group compared to this, which is actually what t-test also does. But this is like a multiple t-test within a group. So you can see here that it will compare this, it was not. Then the same thing it will do across all of them. Then after you have done this, it will now take the second one again. I used to compare to check whether also there is also significant difference between them. So basically, that is all what we will be done. So is that clear?
I want to ask,
Okay.
and using this ANOVA t-test chi-square,
Mm.
was it for one data?
No,
If
depending on the yes, you can have a data set that require different multiple level of statistics. For example, now this data we are examining,
okay,
this data set.
mm,
Inside this data set, you are going to do both ANOVA,
okay,
you're going to do t-test, then you're going to do chi-square.
chi-square.
You are even going to do correlation, you are going to do regression. for
Okay,
this one
inside this
test.
particular
So
data
it's
set.
based on the research questions you are answering. For example, now, if one of your research question is to check the, let's say, the FSH level and the between the cases and the control, what statistic
Mm,
do you think you will be using to check between cases and control, FSH and LH? Remember that FSH and LH are continuous variable, and you are comparing
mm-hmm.
two groups. So automatically that would be t-test.
Okay.
Are you with me? That would be
Yes.
t-test.
Okay.
uh So that would be t-test. Then now in this same data, now let's
Mm,
assume now want to check if age group have impact on the mean value of the age group on
okay.
FSH and LH. Remember
Okay.
that we have four age groups. So because it's more than two, automatically that is going to be ANOVA, because we are
Another.
comparing mean
Okay.
value between groups that are more than two. Are you with
Okay.
me? Then
Okay.
in this same statistic, now you want to check if there is relationship between, let's say, uh, um, let me, okay. Now under these classifications now, let's say ovulation classification. Now you don't want
Mm,
to check, okay, um, between the cases and the control, how many of them are likely to have ovulation?
mm,
And how many of them are not likely to have ovulation? So
mm.
this one now we have converted all this numeric data into categorical data. So when
Okay.
you are now comparing, relating this outcome now with this outcome, automatically you are dealing with chi-square.
Okay. Chi-square.
Yes. Then if you
Okay.
now want to check the relationship between one group, let's say you want to check, is there a relationship between FSH and LH um of the cases?
Mm,
Is it that now when we are saying now, does uh increase of FSH, does it also increase LH?
mm-hmm.
You have to do correlation for that one.
For
You
them.
correlate.
Okay. Okay.
So trying to check, okay, if if um if FSH is increasing, does it equally increase LH?
Okay.
And if it's increasing, in what direction? Is it positive or negative? Because
Okay.
if it's positive, what we are saying is that if it's a direct relationship, if one is increasing, then the other one will be decreasing. But if it's an
Okay.
indirect, if it's a direct relationship, rather, if one is increasing, then the other one will be increasing. But if it's an inverse relationship, if one is increasing, then the other one will be decreasing. Are
Decreasing.
you? Yes.
Okay.
So if you now want to check for risk factors, then that's when you now do regression. So I don't know if I
Okay.
answer your question.
Yes, yes. Like I'm trying to grasp it because all these ones are from the research questions now.
Yeah, it's
From
based
research
on all
question.
these are going
This
to base on research
on the
questions. That's
research
what we're going to
questions.
determine. Yes, the kind
Okay.
of statistics you're going to be using.
Mm, okay. I'm getting it now. You know now when we did that research like some years back, we're trying to
Yeah,
remember and I don't have my
yeah, that's
materials here to start going back. That's the
no problem. Just try and get
mm,
some
yeah.
material to. Yes.
Okay.
Okay. So any question?
For now, no question. For now, at least today on was. I tried to grab today on.
Okay. So
Mm,
tomorrow, basically, what is left for us to look at now is we'll look at correlation, then we'll look at regression. Then
regression.
yes, then the class comes to close. Then if there's any question, you cannot ask on the
The
group.
group. Okay.
Yes.
Then no problem. Grab it.
For this guy, is there any question?
No, none from me. However, is it possible to get the link to this particular class, like maybe this night or tomorrow morning?
I will try to see if I can get it across to you guys today.
All
Okay.
right. Thank you very much.
Okay.
No
All
problem.
right. Good night and God bless you.
Yeah, you
Thank you.
too. Thank you for your time.
Good night.